Vanina is going to work through the first 13, 14 or so. I don't remember what number we said. And then I am Johnny. I will work through the rest. Vanina, take it away.
Okay, so the first step we're going to do here, we're going to get rid of parentheses by distributing this 4 into both the first and the second term. So for this one, we get 20x, and 35 times 4 is 140 equals 100. Now we need to isolate the x. So the first thing we're going to do is subtract 140 from both sides of the equal sign. This one here will cancel, bring down the 20x. 100 minus 140, that's negative 40. The 20 is being multiplied by the x, so to eliminate it, we're going to divide both sides by 20. This 20 here cancels, so x equals negative 2.
Quick thing, you positive 40.
Oh, positive 40?
Yeah. I mean positive 20. Sorry, positive 20. 160 minus 140.
Oh, that's 100, sorry.
No worries. Oh, it's 100. Aha. Okay. Keep going.
Okay.
just kidding.
Okay. Question number 2. You muted. Okay.
So you want me to clear it or you clear
I
it?
can clear.
Oh, okay. All right, cool.
I'm going to clear. And then we have another equation. First thing we're going to do, we're going to start by getting rid of parentheses, distributing here and here, and then eventually here and here. So I'm bringing the terms that I'm not using. So I get negative 21y plus 24 equals negative 2 plus 16 minus 4y. I have these two like terms here. I'm going to go ahead and combine them. So I get negative 26y. I bring down the 24. Also have these two like terms here. That gives me 14 minus 4y. Now I'm trying to combine like terms again, but this I have negative 26 and negative 4. Since they're not on the same side, I'm going to start by adding 4y to both sides. So this gives me negative 22y, bring down the 24, equals 14. This one cancels. Now I'm going to subtract the 24 so I can have it together with the other like term, the 14. And this cancels, so negative 22y equals negative 10. Needs to cancel this negative 22, so I have to divide since it's being multiplied by the y. Divided on both sides. That cancels. So now I have that y equals 10 over 22, which can be simplified by dividing each side by 2. Is everything good, Johnny?
Looks good to me.
So 5 over 11. That's your final answer.
All right.
Okay, let me clear this up. All right. Although fractions are our friends, I'm going to get rid of them to make this easier to solve. So what do I like? I like to find the LCD which in this case is 4, and I'm going to multiply each term by the LCD. So I'm going to multiply this by 4, multiply this by 4, and multiply this by 4. Should I be more thorough?
Maybe mention why 4 is the LCD.
Okay, so LCD is the lowest common denominator, and there's a few ways to find the LCD. And the easiest way to find it in this case, because these are small numbers, you could literally find the least common multiple, because LCD is also called least common multiple. So the multiples of 2 are 2, 4, 6, and so on and so forth. And the multiples of 4 are 4, 16, 20, and so on and so forth. Basically, on the first one, I was just adding 2 more to get the multiples. And on the second one, I was just adding 4 more. So the least common multiple between these two is 4. So now I'm just gonna multiply 4 times 1/2. I could just put a 1 under it and then multiply across. That would be 4 over 2x. I can do the same over here, put a 1 over it, and that's 4 over 4. I don't need to do it here because they're both whole numbers, and that's negative 20. Now I'm going to simplify 4 over 2, that's 2x, plus 1 equals negative 20. I'm solving for x. I'm trying to get x by itself. I start by subtracting 1 from both sides to eliminate the positive 1. This cancels. So 2x equals negative 21. And I'm going to divide both sides by 2. And that's my final answer. X equals negative 21 over 2. Okay, we're going to go to question 4. All right, so I'm solving for L. So basically, I'm trying to have L by itself. Just like in a regular equation, the first thing I'm going to do is I'm going to get rid of the term that's next to the term in question that I'm trying to get rid of. So I'm going to subtract 2w from both sides. Now, I cannot say this is 2pw because these two are not like terms, but I can just simply bring them down together as such. So p minus 2w equals 2l. These two cancel. I want the L by itself. This is being multiplied over here. So I'm just going to go ahead and divide each side by 2. So this cancels. And to make it a little bit more conventional, I'm just going to flip the L to this left side. And although this is my final answer, there are other ways that I can write this. So I'm just going to put all of them here, or at least a few, just in case. So I have that. I could also write it like 1/2 p minus w, because what I basically did over here, I broke it down to p over 2 minus 2w over 2, and then I simplified, and it gave me this. I guess another way, just one more way that you could write this, it would just be p over 2 without bringing the 1/2 out, minus w.
Yep, good. And then I just want to add, if you are taking a class from an Osceola campus-based professor, you would be doing your final exam using IMath AS. And so just be sure when you enter your answers, like for an answer like this, then you click the preview button to make sure what you typed is what you meant to submit. Because if an answer like this, sometimes students will get the right answer, but they don't type it properly. So just kind of keep an eye on that when you're working on it.
I think usually it helps if you have two terms, put parentheses on around it.
Yeah, I agree. Hush, Nyla. Oh my gosh, my dog is so loud.
Okay, now we have an inequality. It's saying to graph the solution. So in order to do that, of course, we got to solve it first. So you can pretend that that is the equal sign and then proceed the same way as you would if you were solving an equation. I'm just bringing it down because of that. All right, so first thing I'm gonna do, oh, where's my 2? I'm gonna subtract 2 from both sides. I like to put them under its like term. This cancels. Now I have 12x greater or equal than negative 21 plus the 7x. Now I want the 7x together with the 12x, so I'm going to subtract it from both sides. 7x. So 5x is greater or equal than negative 21. Again, I have a 5 being multiplied by the x, so I'm going to divide it to cancel it out. This cancels, so x is greater or equal than negative 21 over 5. Now we need a number line to graph this. It helps when you have a number line for you to have some reference points. So I usually have 0, I have negative infinity, positive infinity. This is a continuous line. Now I can go ahead and put exactly 21 over 5 where it goes, but it doesn't really matter at this point. So I know it's a negative number, so I'm going to put it somewhere over here. Let's say that's negative 1 over 5. And it's saying it's greater or equal. So x is any number that's greater or equal than this number. Any number greater or equal than that goes to your right. And this, since it has this little equal component, that means this is a closed circuit at that number, meaning that this number is actually included in this interval. And I think I'm going to go ahead and also write it in interval notation. So since it's included, I'm going to have negative 21 over 5 going to infinity. So included, brackets, infinity is never included, so always parentheses. Okay, so now we have problem number 6, which is a word problem. I know everybody loves those, me included. So the first thing it says is that a rectangular room is 4 times as long as it is wide. That can be written as such. The length is 4 times as it is wide. We also know that the perimeter is 80 meters. So the perimeter P is 80. And the perimeter formula is P equals 2L plus 2W, which is basically just adding the sides, the 2 long sides and the other 2 smaller sides. And I'm going to use that formula, substitute the values that I know so I can get the width of the room. So I know that P, like, let me do it here. P equals 80. Then I have 2 times L. I know that L is equal 4W. And then 2 plus the 2W. So 80 is equal, distribute, that gives me 8W plus 2W. 8W plus 2W is 10W. Gonna divide by 10 to cancel this 10 here. Do it on both sides. So my W, my width is 8, which is what they asked me for. Number 7. All right, so we have that Lisa has a rectangular room. So let me just attempt to make Lisa's room over here. That's Lisa's room, okay? It says that the width, 20 feet wide, the width, W, is equal to 20. It's saying here that the length, this part over here, length equals is 5 feet less. Whenever you hear 5 feet less, put it at the end. 5 feet less, so minus 5 is then twice the width, 2 times the width. And now it's asking me for the area of the living room. So the area formula is A equals L times W. So I have all the information that I need. So the area is going to be the length, the length, which is 2 times W, but W we already know it's 20, so I'm going to plug it in. So 2 times W minus 5, and everything is times W. And W is 20, so times 20. So I'm going to work my way through this. So 2 times 20 is 40 minus 5, everything times 20. So the area is 35 times 20, which is, let me double check. The area is 700 square feet. Okay, so we have a simple interest problem, and we have basically all the information that we need aside from, we have the principal here, 21,000. We have the interest payment here, and we are looking for the rate. So using the formula, I equals PRT. So the interest, which is right here, is $1,533. And that's equal to the principal, which is 21,000, times the rate, which is what we are looking for. So I'm gonna keep it as R. And it says at the end of 1 year. So that's times 1. So solving for the unknown, we have 1533 equals 21,000 R. I'm solving for R, so I need to get rid of the 21,000. So I'm going to divide each side by 21,000. 21,000. This cancels out, so my R is equal to, should I just do it, but the answer, Johnny, or I have to literally do the division?
Well, so in students are allowed to use a 4-function calculator in the class. So I think it's okay if you don't show all the steps for doing it, but I would be sure and emphasize what you put in the calculator, like what order you put it in there.
Okay, so you mean like I would have to put 15 over 33 divided by 21,000?
Right.
Okay. And so your answer is, your rate is 7.3%.
But if they put 1533 divided by 21,000, they get it as a decimal, right?
If it's, let me see what you actually get. So 1533 divided by 21,000. Oh, yes, you're right. Yeah, I went ahead. Okay, so once you did that, you would get 0.073, but rate is always, in this formula, rate is expressed as a percent. So in order for you to get the percent, you would have to times this by 100. In other words, you have to move this twice to the right, and that's what you would get, this 7.3 right here. Okay, so we have an antique has a price tag of $102, and we're trying to find the sales tax. One way that you can do this is just, you can have the sales price, which is 102, times the tax rate. Never multiply percentage as is. You always have to change it into a decimal. So 8.1% is the same thing as 8.1 divided by 100, or just moving this twice to your left, which will give you 0.081. Now you can go ahead and multiply them, and then you have one. That's a 0.81, and 102 times 0.81 is 8.262. And it says here to write your answer to the nearest cent. Cent is the hundredths place, which means you rounding to 100. Looking at the number, this is the number that you want to round. Looking at the number next to it is less than 5, so your answer would be 8.26. So the sales tax for something that costs $102 is $8.26. Okay, this problem is similar in the way you would work it out. So you have a bill that's $70, and you want to find out how much is the tip, is a 13% tip. Basically, what's 13% of 70? Again, you cannot multiply percentage as is. So 13% is the same thing as 13 divided by 100, which means you would move the decimal place twice to your left. So 13% is the same thing as 0.13, times that by the bill, and that would be, let's see, $9.1, I guess, dollars. So you're leaving, If you have, if you go to a restaurant and you pay about $70 and you want to leave a 13% tip, you're gonna leave about $9.10. All right, this one is asking us to find the X and Y intercept for this line. So I'm gonna do the X intercept here, and I'll do the Y intercept on this other side. Whenever you find an X intercept, you make Y, you set the Y equal to 0. And whenever you're finding the Y intercept, you set the X equals to 0. So what I'm gonna do is I'm gonna write down this equation. Whenever I see Y, I'm not gonna write Y, I'm gonna write 0, because that's what you do for the Y intercept, for the X intercept. So that equals 45. This one is going to cancel, so negative 5x equals 45. I need to divide this by negative 5 to get rid of that. Do it on both sides. This cancels out, and my final answer is negative 9. It says for me to write it as an ordered pair. So an ordered pair is always xy, so my x is negative 9 and my y is 0. I'm going to do the same thing on this side, except this time around, whenever I see x, instead of writing x, I'm going to write 0. This cancels out. Now I have 3y equals 45. Divide by 3 on both sides. So y equals to 15. My point is xy. So my x was 0 because I made it 0. And my y is 15. So these are my two ordered pairs for that line. Okay, I'm finding the slope of a line passing these 2 points. First, we need to know the slope formula, which is this one over here. We have y2 minus y1 over x2 minus x1. I always like to label my points so I don't get lose track of what I'm doing. So a point is always xy. So if this first point is xy, x1, y1, the second one is x2, y2. So now all I have to do is this. Y2 is 14 minus y1 is 0. X2 is negative 2. I'm sorry, negative 12. I'm bringing this negative because that belongs to the formula. It has nothing to do with the point. And x1 is 15. Now I just go ahead and just solve. 14 minus 0 is 14. Negative 12 minus 15 is negative 27. Can also write it like I like to put the minus right here next to the fraction. And this cannot be simplified as 14 is prime. All right, now we're finding slope of a line. So slope is rise over run. So rise, up and down. Did I write run? Run. And run is left, right, and left. So first, when you're finding slope, you gotta have a starting point. So your starting point, you always start on your y-intercept, which is this line over here. So as you can see, I'm starting right here. This is my starting point. In my rise, like I said, I can either go up or down. So if I want to meet this line over here, this point over here, I'm going down. So I'm going down 1, 2, 3 times. If I went down 3 times, I'm going to write -3 for my rise. And then I went 1, 2, nope, that was a bad decision. That's not a clear point. Can you bring it up just a little bit? Let me pick another point, Johnny. Oh,
Sorry, hold on.
all right, let me clear the drawings. I'm going to start from the beginning. I'm going to pick 2 better points.
I think
I'm going to pick this
go
one.
with maybe here.
And I'm gonna pick, still gonna pick this one over here. Okay, like I was doing, so my rise. It is very important to pick 2 clear points. And also I'm gonna show another way to do this aside from going up and down, because you can also pick 2 points and use the slope formula to find the slope. So my slope is gonna be for my rise. So I'm trying to go over here. So I went 1, 2, 3, 4, 5 down. So that's -5. And then I went 1, 2, 3, 4 over. So my slope is -5 over 4. And like I said, one other way this could have been done, you could just pick 2 points, like it could be the same 2, it doesn't matter. So this point right here, which is in the y-intercept, since it's in the y-intercept, you know the x is 0, so that's 0, 3. And then you have this point, which the x is 4, and the y is -2. So 4, comma, -2. I'm going to use the slope formula. If I did the top part correct, I should be finding the same exact answer. So remember the slope formula was m equals y2 minus y1, x2 minus x1. I label my points, xy, xy. If this is x1, y1, this is x2, y2. So then I'll have my slope is going to be -2 for y2 minus the 3 for my y1, and then x2 is 4 minus x1 is 0. So my slope is -5 over 4. So either way, it works. Okay, we are finding slope. Okay. If we need to find the slope, the equation needs to be in this form. Y equals mx plus b, where your m is your slope, it stands for movement, and your b is your y-intercept, which is your beginning. So if I want this in this same form, I need to solve this for y. I need to have a y equal, just like here, y equal. First thing is first, I'm gonna add 2x to both sides. This is gonna cancel. I'm left with 3y equals 12 plus 2x, because I'm adding down. However, since I want it in this form where I have a term with an x first, I'm just gonna do a little bit changing stuff over here so it looks like that. So I'm gonna recopy this, but I'm gonna put the term with the 2x first. So the 2x is positive and also the 12, so I have 2x plus 12. Next step, I need this with the y by itself, just like here. I'm gonna divide 3 everywhere to each term. So this cancels, y equals 2 over 3x plus 12 over 3, which can be simplified to 4. I'm going to write it right here next to the formula, well, the form, so you can see how they look alike. So I have y equal, then I have a number with an x next to it, and then I have an independent number. So this is my slope right here. Once I have this in this form, my slope is just going to be that number behind the x.
Am I on now?
Oh, you were trying to talk?
No. Is
Yes.
am I next?
Yes.
Oh, okay.
I was having fun. Okay.
Yeah, I know. You can keep having fun.
All right, let me see what comes next. If it's
Okay.
something I don't like, you can do it. Okay. I guess since I was doing all this,
Oh,
I guess
let me change the view. Hold on.
okay. Oh, okay. All right, so back to the slope intercept form, which y equals mx plus b. One thing, the easiest way to find the best graph is looking at the slope. You see that it's negative, right? If it's negative, you know the line should be going down. So I'm gonna go ahead and eliminate this guy over here. And let me see, this one is going down, this one is going up, and I'm also gonna eliminate this one. And if you wanna know, how do you know it's going up and down or down? Always imagine like you're a guy standing right next to the graph, to the left of the graph. If you right here, you're going up. If you right here, you're going down. So this is up, down. So now it's between this one or this one. What I like to do, I look at the y-intercept. The y-intercept is 1. So I'm going to go ahead and eliminate this one as well, because as you can see, the y-intercept is -1. So the only one that works is this one. So this is my graph. You want to add something, Johnny?
No, you did. The slope is negative, it goes down. No, that's good.
Okay.
Let's see.
All right, so now we're going to be doing a little bit of simplifying. You can only add like terms. So I'm going to go ahead and I have this one and this one. I have this one and this one, and those are the only like terms that I have. So I'm going to rewrite this and put them next to each other. So I have -7x to the 4th minus 10x to the 4th plus x cubed. Actually, one thing that I want to mention is that it helps as you put them down, like cross them over. That way it gets less confusing. So the x cubed, I already put it down, plus the 3x cubed. Now I'm left with 2x and the -9. So same sign. So I'm going to be adding and keeping the sign. So that's -17x to the 4th. Same thing here, same sign. So I'm adding. So that's 4. Don't forget the imaginary one over here. That's 4x cubed. Can't do anything with these two because they are not like terms. This one is just an independent term. This one has an exponent of 1, so I don't have anything else to do with them. Okay, so now simplifying. So I have this, I can rewrite this. This is the same thing as 2x minus 1 2 times because of this 2 exponent. 2x, oopsies. Hold on. I'm going to erase this because it almost looks like a plus in this one. Okay, 2x minus 1, 2x minus 1. Okay, so I have to distribute in order to solve this. So I'm going to times this by this, and then by that, and then, well, let me do it first. So 2x times 2x, that's 2 times 2, which is 4. X times x is x squared. Then I have 2x times negative 1. That's negative 2x. Now I got to do this times this, then this times this. That's another negative 2x. And negative times negative is positive. 1 times 1 is 1. I only have these two like terms. So 4x squared minus 4x plus 1 is my final answer. Okay, now we're simplifying rational expression. Is that what that's called, John?
Yeah, it can be. Yep.
Okay. Yeah, it has a fraction is a rational expression. So we're going to be using the rules of exponent. So in this one, the only one I see that we need to use is whenever you have you're dividing exponents, you subtract the exponents. So what I have here is 6 divided by 3, that's 2. Now that is not an exponent, so I'm not gonna subtract and say 6 minus 3 is 3. That's still a regular division. Now x to the 9 minus x to the 5, I'm gonna keep my base, which is x, and I'm gonna subtract the exponents. That's gonna give me a 4. Same thing here. Keep the base, which is y. 8 minus 2 is 6. That's a freebie for your test. Okay, so I see another set of rules that we're going to have to use here. One that I see is that anything raised to the 0 power, it's 1. So this one would give us a 1. One other rule that I see is whenever you have a number raised to a negative exponent, what you do is you could put a 1 over it and that exponent becomes positive. But one easier way to do this is basically if you have a negative exponent on the bottom, you bring it to the top. If it's on the top, you bring it to the bottom. So this would, the 3 over 0, that would be 1. Now I'm going to bring this to the top and the exponent is going to become positive. So it's going to be 1 times a to the 5th power. So my final answer is a to the 5th power. Okay, we have some more simplifying. Let's see. Okay, so we need to get rid of parentheses. Over here, it's pretty clear. I'm just going to go ahead and write it down. 6x minus 1. Now here I have this negative. I'm going to need to distribute this negative to each term. Just think of it as a negative 1. So each one of these terms, whatever sign they have, is going to switch to the opposite sign. So this is going to become a negative 9x squared. This one's going to become a positive 4x. And this one is going to become a negative 8. Now I'm looking for like terms. I have these two over here. Then I have these two over here. And I'm going to do what I always do. I'll put them next to each other. That one is out. This one is out. The negative 6x is out. The positive 4x is also out. And then I have negative 1 and negative 8. Now, this seems like too extensive to be doing all this, but I think if you want to get it 100% correct without missing any points or getting yourself entangled with these, just do this extra step. It doesn't cost you anything. So 4 minus 9, different signs. So I'm going to subtract, keep the sign of the bigger number, which is negative 9. That's 5x squared. Same thing here. I'm going to subtract because they have different signs. And I'm going to keep the sign of the bigger number, which is the 6. So this gives me a 2x, negative 2x. Right here, same signs. You add and keep the sign. So negative 9. Final answer. Want to take over, Johnny?
You're having so much fun. No, sure, I can do that. I was waiting for your cue. Okay.
Okay, go ahead.
All right, let me. I should have changed it to be white again. Okay. All right, so we're still simplifying polynomials. So this problem is asking for us to multiply two binomials, which Vanina did earlier when she rewrote a binomial squared. But you can use an acronym. You're basically distributing, but you are also doing something when you're multiplying two binomials. You can do what's called FOIL. And so that's when you multiply the first two terms. So in this case, it'll be 3x times 4x. And then you'd multiply the outer terms. So 3x times negative 3. So positive 3x times negative 3. And then the inner terms. So that would be negative 4 times 4x. And then the last terms, negative 4 times negative 3. Okay, so now we're going to multiply everywhere. So 3x times 4x will be 12x squared. 3x times negative 3 is going to give you negative 9x. Negative 4 times 4x is negative 16x. And negative 4 times negative 3 will be positive 12. So now we're going to combine like terms, and we have them here in the middle. So I'm going to bring down, okay, I need to tell my son to close the door. 12x squared, negative 9x minus 16 is going to give me negative 25x plus 12. Okay, and that's going to be our final answer because there's no other like terms to combine. Hold on, let me tell my son to close the door. Okay. All right. Next one. So now we're going to do some factoring. Yeah, that's good. Okay, sorry. So this one, so there's lots of different ways that we factor polynomials, and we're going to look at a few examples of each type. It depends on how many terms you have in a polynomial that determines what steps you would take. So when you factor any polynomial, the first thing you want to always check for is to see if there is a greatest common factor, a GCF, in the entire polynomial to factor out. Sometimes there is, sometimes there isn't. In this case, there is not a common factor to factor out of every term. So now we're going to go with the procedure when we have 4 terms. So the way that we factor a polynomial with 4 terms is by what's called grouping. So the first thing you're going to do, you're going to group the first 2 terms together, and then you're going to group the second terms together. Now notice that I included the negative in here, and you'll see why in a second. I'm going to factor that out later. So now in each group, we're going to factor the greatest common factor from each smaller group. So in this first group here, xy plus 9y, the GCF is y. So I'm going to factor out y, and then what I have remaining, and when you factor out something, you're basically kind of dividing it out of everything. So when we factor a y out of the first term, we have just x, and then we factor y out of 9y, we're left with 9. And you can always check to make sure you factored right by going back and multiplying it back. So y times x is xy, y times 9 is 9y, so we're good. So now we're going to factor out the GCF of the second pair. So we've got negative 5x minus 45. So the trick with factoring by grouping is that you want to have the same binomial here. And I like to call them the twins. You want to end up with the twins when you factor by grouping. So that means I need to factor whatever is necessary to end up with x plus 9 in here. Okay, so what would that be? The greatest common factor here is negative 5. So remember I said I was going to factor out that negative, so now I'm doing it now. So when I factor out a negative 5, I'm left with positive x. And when I factor negative 5 from negative 45, I'm left with positive 9. So now I've got what I mentioned before. We've got those twins here. So x plus 9, x plus 9. So now I'm going to just write, I like to write the twins. So you just need to write it one time because you're basically factoring that out. So you've got what's in common here and here, x plus 9. So we basically factor that out. And when we factor that out, what are we left with? Just y minus 5. So that is our final answer. And again, you can always check to see if you factored something correctly by multiplying it back together. So just to kind of show you, I won't do this for every single one, but we can check our factors. So to check it, we're going to FOIL it back together. So x times y is xy, x times negative 5 is negative 5x, 9 times y is positive 9y, and 9 times negative 45 is negative 45. And even though it's not written exactly like it was up here, we know it's the same thing. So we know that we're good to go. So that's factoring by grouping when you have 4 terms. I'm going to actually come back to this one. I'm going to do this one first. I know it says solve by factoring, but this is a little easier trinomial to factor. So I'm going to do that first and then go back and do the other one. Okay, so first let's pause on solving it. Let's focus on factoring right now. So I'm going to factor this trinomial. So I'm just going to rewrite it so we know what we're doing. Okay, so like I said, you always check to see if you have a GCF, a greatest common factor, to factor out. In this case, we do not have a greatest common factor to factor out, so we're going to go straight to factoring. Now, when you have a trinomial, when you have 3 terms, there's actually a ton of different names for how you would factor this. I like to factor this by starting off with what I'll call the sign rules. I like to set up my signs in my binomials and first, and then I get my constants and terms to put in there. So basically, when you factor any trinomial that's factorable, you're going to end up with 2 binomials. And so this is m squared. M is the variable in this trinomial. So we're going to start off with m and then an m, because again, if you were to multiply these together, m times m is m squared. So now, how do I set up my signs? So what I like to do, I drop the first sign. So if this is positive, then this sign will be positive. Then to get this next sign here, I'm going to just multiply positive times a positive. So positive times a positive is a positive. So I'm halfway done with factoring this trinomial just by putting my variables and my signs in here. So now I need to get what numbers go in here. So when you are multiplying, sorry, when you're factoring a trinomial, you need to get two numbers that will multiply to give you this 108. And let me just kind of show you the standard form. So this is the standard form for a trinomial. You're trying to get two numbers that multiply to give you the C, which in this case is 108, and add to give you that B, in this case is 21. So 108 is kind of a big number. So how in the world can I get those two numbers? Sometimes it's, you know it easily, and sometimes you have to do a little work. So I'm going to show you what I would do if I wasn't sure of my two factors. How can I come up with that? So 108, I know that 108 can be divided by 2. So I'm going to use a factor tree or part of the factor tree to help me come up with two factors that multiply to give me 108 and then add to give me 21. Well, I know 54 times 2 is 108, but 54 plus 2 is definitely not 21. So let me keep playing around with my factors. So if I break down 54 further, let's see, 9 times 6 is 54. So the neat thing about this process here is that I can use these numbers to help me come up with some more factors that multiply to give me 108. So for example, I could do 9 times 2. 9 times 2 is 18, and then I have 6. So 18 times 6 gives me 108. Does 18 plus 6 give me 21? No, that does not give me 21. That gives me 24. So that's not going to help me. So let me try something else. So again, I'm just kind of showing you how you can come up with those numbers. Sometimes it's hard to come up with. Let me try a different combination. What about 12 times 9? So 12 times 9 equals 108. What about 12 plus 9? That does equal 21. So you see how I use this factor tree to help me come up with those numbers that I need. In this case, with my sign rules, they're both positive, so it doesn't even matter which numbers I put first. I'm just going to put 12 and then 9. Because using those sign rules, you want to put the bigger factor first, but it doesn't matter in this case because they're both positive. And we're done with factoring this trinomial. Now, because I'm doing this problem, we're solving by factoring. So for solving by factoring, it's set equal to 0. To then solve it, you would use the 0 product property and set each factor equal to 0. And then you would solve each one individually. So to solve for m here, I would subtract 12 on both sides. So m equals -12. And then I would subtract 9 on both sides. So m also equals -9. So that's how you would solve by factoring, but I wanted to show the factoring part here as well because it's a little simpler than the previous problem. Okay, so let's do that. We'll go back to this problem here. So we've got 10x squared minus 27x minus 28. So again, we're always checking to see if we have a greatest common factor to factor out. And I do not have a GCF to factor out here. So I'm going to have to go to factoring using, in this case, the AC methods. Just remember, this is the standard form, ax squared plus bx plus c. So in this case, a would be the 10, b would be the -27, and c would be the -28. So there's a few ways to do this. So I like to do, I don't know, start with the AC method. So the AC method requires that we take a times c, and that number is what we're going to use to help us find our factors to put in our binomials. So in this case, a times c is going to be 10 times that 28, which is 280. All right. So I'm going to write 10x squared, and then I'm going to put minus 28, but I'm going to use this 280 to help me get two numbers in here that will multiply. Remember, multiply to give me the 280 and add to give me negative 27. All right, so we're going to use that same kind of trick to help me find those two numbers. So I'm going to work on a little factor tree. So I know I've got 28 and 10. 28 times 10 equals 280. So I'm going to break this down to 4 times 7. This one down to 5 times 2. So I'm going to play with some combinations of numbers. So I'm going to try 7 times 5 is 35 times 8 times 2 is 8. So 35 times 8 is 280. But it's negative 280 is what we're looking at. This is a negative. All right. So I need to keep that in mind that one of these needs to be a negative number to give me a negative product. And then I need for the sum of these two integers, either whether it's negative 35 plus 8 or 35 plus negative 8 needs to equal negative 27. So it would be this first one here. Negative 35 plus 8 equals negative 27. So negative 35 and 8, that's going to be the numbers I'm going to use. So I'm going to rewrite negative 27x using my two numbers here. Negative 35x plus 8x. Because negative 35x plus 8x does equal negative 27x. And negative 35 times 8 is negative 280. So, okay. So now I've got 4 terms here. So I'm going to use grouping to factor this. So I'm going to group the first 2 and the second 2. So I'm looking for a GCF out of the first 2 terms. So this would be 5x. When I factor out 5x times 2x gives me 10x squared. 5x times negative 7 gives me negative 35x. So now I'm going to factor out the GCF here. And remember, we're trying to get that same 2x minus 7. If I can't get that same 2x minus 7, then either I did something wrong or maybe it isn't factorable. So I'm going to factor out a 4, a positive 4. When I do that, 4 times 2x equals 8x. And then 4 times negative 7 equals negative 28. So now I've got my twins here, 2x minus 7, 2x minus 7. So I'm factoring that out, 2x minus 7. And then what's remaining, 5x plus 4. Okay. I'm going to show you another way to factor this, still using the AC method, but then using something different right after that. So do I have room? I got a little room, probably a little smaller. Okay, so I had 10x squared, what was it? Minus 27x minus 28. Okay, so method number 2. So I'm still going to do that 10 times negative 28. What I'm going to do when I get that AC, I'm going to make that be my new C in like a new trinomial. I'm going to drop the 10. I'm just going to bring down that x squared minus 27x minus 280. So I'm getting that minus 280 from the AC method. So now I'm going to factor this kind of new trinomial I made up using the sign rules that I mentioned earlier. So I'm going to start off by setting up the binomials. I need x times x. So I'm going to drop the first sign. So in this case, if this is negative, that means this is negative. Then to get the next sign, I'm going to do negative times a negative. That's a positive. So now I got to get my two numbers that multiply to give me 280. And then since 280 is negative, they should subtract to give me 27. Because the nice thing about doing the sign rules first is that you don't have to worry about the signs when you're coming up with those two numbers. You've taken care of the signs in this stage. So again, two numbers that multiply to give me 280 and subtract because 280 is negative to give me 27. So we already found those numbers, 35 and 8. But whenever you use these sign rules like this, you have to put the bigger factor first. So I'm going to put 35 here and then the 8 here. But remember, I'm not done because that would not be what I got earlier. When you multiply that 10 times the negative 28, you have to kind of undo that now. So what you'll do is you'll now divide by that 10 here. And then from there, you're going to simplify, reduce your fractions as far as you can go. And then once you have reduced them as far as you can go, if you still have a denominator, you're going to, some people call it slide and divide. Some people call it bottoms up. You can call it whatever you want. But so in this case, I can simplify 35 over 10. I can divide them both by 5. So that would be negative 7 over 2. And then I can divide the 8 over 10 by 2. So that would be 4 over 5. So I've simplified the fractions as far as they can go. Now I need to do the slide and divide, or the bottoms up. So I'm going to drag or bring this denominator, slide it up. That's going to actually end up being 2x minus 7 times 5x plus 4. And so that's my same answer. So I would suggest that you as you are learning these or hopefully reviewing these at this point, there's a lot of different methods. I just wanted to show you 2 different ways. And then when you practice factoring, you use the method that makes most sense for your brain. Because as long as you're getting the correct answer, it's okay. So, okay, it took a long time for that, but I want to show you those 2 methods. So the next one, you're still factoring. You still want to check for a GCF first to factor out, which in this case, I don't have one. I have 2 terms. So in this class, in developmental math combined, there's only one way. So there's 2 ways you can factor a 2-term, a binomial. If there's difference of squares or sum and difference of cubes. In this class, developmental math combined, you only learn difference of squares. So when you get to intermediate algebra, you'll have a few other ways you can factor. But in this class, the only way you can factor a polynomial with 2 terms is by using difference of 2 squares. So a squared minus b squared. It would need to both be 2 squared terms. And the way that you would factor that out is that you would just expand it by doing a plus b times a minus b. So the important thing is figuring out what your a and what your b is. So what are the bases for these 2 squared terms? So for the first one, 64x squared. So 64 is a perfect square because 8 squared equals 64. 49 is a perfect square because 7 squared equals 49. So what we're going to do is rewrite 64x squared as something squared. So 64 is 8 squared. I'm going to write 8x together, put it in parentheses, and square it because this will equal 64x squared. And then 49 we just said is 7 squared. So now 8x is like my a, And 7, no, I want a different color. Didn't work like I wanted. Oh well. 7, well, it's green now. 7 is my B. So everywhere you see A, you're going to write 8x. And everywhere you see B, you would write 7. So that would be 8x plus 7 times 8x minus 7. So the important thing with these is to know how to rewrite them in the a squared minus b squared format. Because then once you know what your a and your b is, just plug it into your factored form. Okay. All right. So we did this one. Okay, similar triangles. So the triangles below are similar. Find the measurement of the missing side of the triangle pictured below. So, okay. With similar triangles, you would use proportion to solve for the missing side. So in this case, this side 10m. So I like to kind of, if you think about it like proportional. So if you were to take this triangle here, but similar triangles have proportional and congruent sides. So 10m is proportional and similar to the xm. So what you can do is set up a ratio. So I could say 10 over x equals, I would need to set up that same ratio using other sides. So in this case, if I did 10 over x for the first ratio, that's proportional to 7 over 21. I would not want to do 10 over x equals 21 over 7 because you would have mismatched the order. So now I've got a proportion to solve. You can solve this a few different ways. I'm gonna multiply both sides by the least common denominator of 21x. So if I multiply both sides by 21x, it's similar to when Vanina was solving that problem way early in the review where she wanted to get rid of the fractions. So when I multiply the first side by 21x times 10x equals 21x times 7 over 21. The x's will cancel on the left side and the 21s will cancel on the right side. So then what I'll have is 21 times 10, which is 210. And then x times 7 is 7x. All right. So now to solve for x, I'm going to divide both sides by 7. And then when I do that, I'm going to be left with 210 divided by 7 equals 30. So x equals 30. So that's the missing side length in this problem. Okay. So the next problem, we are simplifying this square root. So the 10, so we have 10b to the 4th times the square root of 121 b to the 9th e to the 4th. So the 10b to the 4th, that's going to just stay on the outside for now. If we bring anything else to the front of the square root, then we will multiply that with that. But for now, we'll leave it there. So now we're going to separate each one. So I'm going to take care of that square root of 121, the square root of b to the 9th, and the square root of e to the 4th. So the square root of 121 is a perfect square. So that actually just equals 11. So I have 10b to the 4th times 11. So now I have the square root of b to the 9th. So you can do this a few ways. So one way to think about it is that if I were to rewrite this as b to the 8th times b, so b to the 8th times b does equal b to the 9th. But the reason why I did that is that the square root of b to the 8th, do that on the side, that is the same thing as, let's see, saying b to the 8 over 2, okay, which is b to the 4th. Another way that you can do that is if I were to expand that and write 8 b's, this is a square root, so I'm looking for pairs. So how many pairs of b's do I have? 1, 2, 3, 4. B to the 4th with nothing remaining, okay? But what do I actually have? I have b to the 9th. So it's b to the 9th. Let me erase this. Then I would have one more b in there. Now, again, looking for pairs, it's a square root. So I have 1, 2, 3, 4 pairs of b, so that gives me b to the 4th, but I still have a b remaining. So that stays under the radical. So when you're doing these back over here, if you rewrite it to where you basically drop it down, drop the exponent down 1, so you have an even exponent. So whenever you have an odd exponent in a square root, if you drop the exponent down 1, and then you write the extra one left over, then you can very clearly see that, okay, so the square root of b to the 8th is going to give me b to the 4th, but I'm still going to have that b under the square root. Now here, the square root of e to the 4th, 4 is even, so I'm not going to have the situation where I have something left over. I'm just going to have, okay, how many pairs of e's do I have? I have 2 pairs. So that's going to be e to the 2nd with nothing left under the radical. So just to kind of show you, square root of e to the 4th is the same thing as the square root of 4 e's multiplied together. I'm looking for pairs, 2 pairs, e to the 2nd with nothing remaining. So that's what we have here. Now, I've got a lot of stuff going on. Whatever is outside of the radical needs to be multiplied together, and whatever is left under the radical stays under the radical. So I've got 10 times 11, which is going to give me 110. So now b to the 4th times b to the 4th. I'm multiplying exponents with the same base, so I'm going to add the exponents. That's b to the 8th. And then I have this e squared outside of the radical, so I'm going to write that beside everything else outside of the radical. And now the only thing I have left over is that square root of b. So that's going to be your final answer here. Okay. All right. Okay, 28. So we have a rectangular pool is 18 meters wide and 24 meters long. So I'm going to just kind of sketch that out. So it's 18 meters wide and 24 meters long. If you swim diagonally across the pool, how many meters would you be swimming? So if I'm swimming diagonally, it will look like that. So it's asking for how many meters would this be? How long is this length? I'm going to make that X. So if it's a rectangular pool, that means that my corners are right angles. So what I basically have here is a right triangle. So when I have a right triangle, I can use the Pythagorean theorem to solve for any missing side lengths. So A squared plus B squared equals C squared is the Pythagorean theorem. A and B is always going to be the legs of your right triangle. And C is always your hypotenuse. So the hypotenuse is always the side opposite of the right angle. So in this case, this X is the hypotenuse in this purple right triangle. And then I should have drawn it the other way because my side's down here. I'll just write it up here. 18. Okay. Yeah. So the hypotenuse in this case is X. So I'm going to change this C to X squared. And then now my legs would be the A and the B. So again, just so we're clear, right triangle, the hypotenuse is always C, and the legs is always A and B. And it doesn't matter which one is A or which one is B. The one that matters is that C is always opposite of the right angle. Okay, so let's make A be 24 squared plus B squared. B will be 18 squared. So now we're going to solve for X. So to do that, we'll need to find 24 squared, which is 576, plus 18 squared is 324, equals X squared. So 576 plus 324 is 900, equals X squared. So to solve for X, we would need to undo that square by finding the square root. So the square root of X squared just leaves you with X. But you have to take the square root of both sides because this is an equation. So we're talking about, now you'll learn this more in intermediate algebra, but you're solving for a square root. You can have plus or minus an answer. In this case, we're talking about an actual distance, a length. So you can never have a negative length. So all we need is the positive answer of the square root of 900. So the square root of 900 is going to be 30. So 30 meters would be the length that you would be swimming if you swim diagonally from one corner to the other. 30 meters. Okay. And I think that might be it for this review today. So few quick pointers for anyone watching this about reviewing for your final. You want to make sure that you practice using your review. All of you should have a review in your class that is in the same format as your actual final exam. Please do that review multiple times. I'm pretty sure it's set for unlimited attempts in your class. So the more comfortable you are with doing the review, the more comfortable you will be with taking the final exam. You want to practice so you know which areas you need to focus more on, and you want to practice a lot to try to relieve any anxiety you may be having about the final exam. Because again, the more you practice, the more calm you are more likely to be when you take the final. And then also practice being timed. So the final exam will be timed. You will have at most 2 hours and 30 minutes to complete your final exam. If you've never practiced being timed, then being timed for the first time can bring you a lot of anxiety. So use that review and time yourself. Just have a timer on your screen or on your phone or somewhere and practice what it feels like to have the timer ticking down as you work on the math problems, because that will help you relieve any stress that you might be having. Remember that online tutoring is available until the very end of final exam week. So they are there ready to help you. And then the link for this review will be posted in the same flyer that you used to find this review session. So if you have any questions, please reach out to your professors. If you haven't signed up for your spring class, please do that as soon as possible. And also, if you have to buy any books, they have free shipping in the bookstore until January 3rd. A little plug for that. So if there's no questions, we'll end this review here. I hope you all have a wonderful rest of the week, a great final exam week, and a great holiday break. Thank you very much.